Sorry, students. I'm just, yeah, recording has started. Okay, so I'm going to start with the outline of the paper. Then I'm going to explain what we're going to be doing today. And then we're going to take it from there. So effectively, your final exam, which you're going to be writing later this month, is going to have 4 sections. I'm sure your lecturers will have told you kind of that it's broken down into section A, B, C, and D. And it's important to know what are the compulsory sections and what are the sections that you can make a decision upon which ones you're going to be studying. So you've got 4 sections. Section A is going to be a compulsory all 3 questions. So in other words, within section A, you're going to need to answer all 3 of those questions. I'll go back and explain what they are going to be in a minute. Your sections B, C, and D are going to be a choice. So section B will be a choice between either, I suspect, grouped or ungrouped. So you will choose either grouped or ungrouped. Class, you can't decide to take one question from grouped and one question from ungrouped. So you will need to decide the strategy you're going to adopt and the section you're going to answer. So as I said to you, I'm just going to look briefly at the way that that paper is structured. I'm sure all of you have seen a copy of it, or not of the paper, but a copy of the way that it has been structured from your lecturers, and indeed also with the attached formula sheet, so you'll know what you're beginning as well. But I'll deal a little bit later with formula sheets. Just be aware at this stage, class, it's an important point to note that most of the formulae are provided. The formulae that deal with your permutations and combinations, and formula that deal with your probability rules, okay, your additions, multiplications, are not given, okay? That must be made eminently clear at the stage, at the fact right at the start, so students must know and be able to apply their permutations, combinations, and their probability rules without a formula sheet. So section A is going to be compulsory. Section A will contain 3 types of questions. Your first question will be definitions. Your definitional stuff from chapter 1, that will be your multiple choice type questions and the question where you match a definition with what it means. So you know, students, you know the kinds of things you can kind of get in this is what is the strongest form of data? What is the weakest form of data? The number of students sitting in a class is a form of what, and we would know that now, hopefully, that it is quantitative data and that would be discrete data. So you need to understand, class, and be able to revise again your definitions, such as a random variable is an attribute of interest. It produces data. Remember, a random variable itself is not data. It does produce data of either a qualitative or a quantitative nature. Those kind of questions are all going to sit in question 1 of your paper, and there will be MCQs and, as I said, the matching up of definitions. Moving to number 2 type question in your compulsory side, class, you're going to have your index numbers. Now, your index numbers, you know, most of you did very well in those first, right across all the campuses, the index number calculations and how to do them. So you would either deal with a Las-Perez or a Pasch, and you would know that with Las-Perez, you are dealing with keeping or holding quantities constant in the base period and Pasch in the current period. And then finally, linear regression, where you provided with a data stream, which is independent, you're provided with a data stream that is dependent, and you run your linear regression finding A and B using the formula that will be provided to you in the back in your formula sheet. So that's your compulsory section. Class, that should be, I suspect, 40 marks out of 100. And I would also suspect most of you have got pretty decent marks at this stage. So those you'd probably, if you know your stuff, which we'll talk about, you'll easily get between 35 and probably even close to 40 in that section. So that, I think, is not so much of an issue. Section B, Section C, and Section D are all going to be choices. So in Section B, you will choose between grouped or ungrouped data. So in other words, your ungrouped data will be one long line of data where you're going to potentially need to calculate a mean, either a first or a third quartile, and of course, always your standard deviation. I must again remind you, students, if you go the ungrouped route, please know your standard deviation calculation. It's easy to do, but some students get it kind of confused. So please go over your standard deviation calculations again for ungrouped data. Now, ungrouped data classes, you know, is one long line of data, and that's generally the first question that you come across in this section B. You can alternatively choose your grouped data, and your grouped data will, of course, be data that is reflected in a frequency table where you will have intervals, say, between 20 and 25, 25 to 30, just under, those ones. And then, of course, you're going to use the formulae that are provided to you in the back to be able to calculate. Most notably, they give you calculations on means and modal values, and probably either first or third quartile. Those are the kinds of questions that generally pop up in your your group data. Always remembering, while I'm thinking about it, for your ungrouped data class, always be able to draw a bar chart, always be able to draw a pie chart. Generally read the question carefully. If they ask for bar charts, class, they could also ask you either for the raw data or for the percentage breakdown. They can ask either. So read that question before you charge off and draw it, making sure, of course, as I'm sure your lecturers have told you, that your bars must not touch. This is in terms of ungrouped data, and that your very first bar shouldn't align or touch your y-axis. But again, as I say to you, we're just revising this information at the moment because I want to spend a lot more time on the statistical side of hypothesis testing and stuff like that. Section C will be a choice. So each one of these, B, C, and D, are going to be 20 marks each. So that's for 60 marks. And of course, your section A, which is compulsory, will be for 40 marks. Now, section C will be broken down, and this is probably where I'm going to be starting this complete lecture, because class, the other two, section A, where you got definitions, index numbers, linear regression, and your grouped and ungrouped, have been dealt with fairly comprehensively in the previous two master classes that I've presented to you. So I'm not going to waste your time going back over those when I need to spend time, more importantly, on probability measures and being able to measure, and particularly I need to spend time on sampling distributions and hypothesis testing with you today. So section C will have two questions, of which you will answer one. And the first type of questions will be very similar to the type of questions you had in your second test. So in your second test, you had probability type questions, which dealt with your frequency tables and working out probabilities of what is the probability of randomly selecting a female from the collection of people. What's the probability of finding somebody who likes Apple and, choosing a male and Huawei, or anything, depending on what they are talking to about. So their class, you're going to use your rules of probability, the addition, the multiplication rules that are not going to be given to you in your formula sheet, so you must know them. In also probability section, class, please note that it's not just the probability table. You must also revise your probability trees, and please also revise your permutations and combinations. Those are critically important. Again, class, I don't think I made this point effectively last time. because I was under the impression, I think most students knew that your permutations and combination formula weren't provided to you. They've never been provided to you, but I'm making this point now explicitly in this program presentation for all students. Remember, your permutation, your combination formulae are not provided to you in the formula sheet, nor are the other probability type formulae. So your addition, your multiplication, your conditionals are not provided. So please revise them if you're going to do that first section. Now, this is where I'm going to catch up and start now with you guys, is on the second section. So from now on, this is where I'm going to be taking you through, is on probability distributions. I'm going to go through it very slowly. So that would be the second section of section C. And those questions are going to include binomial distributions and a Poisson distributions. Generally, class, and I can't say this categorically, but they generally will give you a binomial rather than a Poisson because there's more calculation involved. But please, I don't know what they're going to give you. So they could give you either. So I'll spend a bit more time on binomial, and then you will get a continuous probability calculation. This is in section C, second question. And then, of course, you'll probably get a sampling distribution question. So the way that the paper is structured, at this stage, class, my suggestion to you is, given the fact that all of us as lecturers have gone through all the through all the sections, my suggestion to you, all of you, is to sit down and think of the areas that you feel most comfortable with. Okay, section A, you have to deal with all of those questions. So there's no getting around it. But section B, you can quite honestly say to yourself whether you feel more comfortable with grouped or ungrouped. Then in section C, do you feel more comfortable with probability in terms of that table and combinations and permutations and a tree? Or do you feel more comfortable with the work we're going to start now? All right. And then when we get to it, we're going to get to section D in the fairly soon. Okay, so class, that's where we are. That's your paper. It's going to be out of 100 marks. It'll be 2 hours. All your tables, okay, your tables. So your Z, your T, and your chi tables will be provided to you. Your formula sheet will be at the back. My suggestion is when you get your paper, undo the formula sheet and the tables straight away so you don't have to keep flipping backwards and forwards. Also know what you've got. And again, let me re-emphasize, please, if you can, go and ask your lecturers to get you a copy, and I'm sure there's available on the website what actually is in that formula sheet and what you need to actually, where you can find it quickly. That's more importantly, where you can find the relevant formulae for the relevant sections, and also remembering that you don't get those probability formulae. Right now, class, it would take far too much more of my time, and I would bore you if I started right from the beginning. Now, I've done sections A and B and C fairly fairly comprehensively, sorry, in the last 2 master classes. You can access them very easily. So I've broken it up, and you can go back over those. What I want to do with you today is deal with the most recent stuff that your lecturer has dealt with, starting with probability distributions and then working our way through to hypothesis testing and to chi tests. At each section I'm going to go through, class, I'm going to tell you the areas to look for, where you apply your formulae. I don't know, all of you, your lecturers have done this with you, but it doesn't do any harm to just do a bit of revision now and again. So I'm going to start with probability distributions. So class, to put it into context, this would be a section C, section C question, probably the second part of it. So in other words, the first part would be probabilities, probability trees. And it probably, I would think, would be a section, kind of a question 6 maybe, and this would be a question 7, depending on how the paper's structured. Always remember, you can't kind of mix and match. You've got to either do a question 6 or a question 7. Again, class, from an operational viewpoint, please be aware that as lecturers, we can only mark your first. So if, for instance, what I'm saying is you get to section C and you start with question, I don't know, let's say 1, 2, 3. Let's say you're going to start with question, a first question, and then you find you don't know it all, then scrub it out, put a line through it. Because if you don't do that and you do some additional second question and you don't put a line through the first one, we are forced to mark the first question no matter what. So if you don't show us that you have put a line through it and there's more work underneath, you will get marked on whatever comes first. So please remember that. I'm sure your lecturers have told you that. Okay, so I'm going to start with probability distributions. We're going to start with, hang on, let me just go back one. My apologies. We are starting with probability distributions. And I want you, first of all, this is a section C, second type of question. And what I would like you please to understand is that there are two main categories that we are learning of probability distributions, okay? So the first one is known as discrete. And those two that we're learning for us in this stats course is something known as a Poisson and a binomial. Now, they are different probability distributions that deal with different types of questions, okay? So they each deal with a particular case or class, should I say, of question. They can't be used together, all right? The question type is different. So when you have a binomial, it's answering a different question to a Poisson. Now, I'm going to also speak to you about why they're called discrete and continuous. Okay, so discrete is dealing with individual data. Now, please, class, all of you, remember when you go back to chapter 1 in your book, the difference between discrete and continuous. Discrete data is data that is such as the number of students in a class, the number of cars on a road, the number of aircraft on an apron at an airport. In other words, it is a number that cannot be fractionalized. So you cannot have half a car, half an aircraft, half a student. But your continuous on this side can be fractionalized. Okay, that is why you have a continuous curve here. And we find probabilities under the curve, and that's when we use our Z and our T tables, or we go on this side and we use discrete data, and the data that we're using is dealing with cars or humans or whatever else, things we cannot fractionalize. So in our learning, we start with discrete and then we move to our continuous. Now, there are two types of questions when I say two types, there are two classes of questions they can ask you, class. Now, the first kind of question is what is the probability that something of so many successes will occur in a randomly drawn sample of so many objects, okay? So one has to just visualize what they're trying to do here. So the question will start off something along the lines of, you're running a website. Let's say theoretically you're running a website and you find that 1 out of 4 people, so people are discrete, it's a discrete distribution, 1 out of 4 people make a purchase of 500 Rand or more on your website. Okay, that's given to you. So that is a success in inverted commas, but we'll look at an example in depth. It's giving you a context. Then the question will be let's say you randomly draw 12 or 13 people from your website and you wish to know what is the probability that maybe one will make a purchase of 500 Rand or no more than 2 will make a purchase of 500 Rand, etc. So your class of question is a type of question that you are looking at. It's kind of a collectively exhaustive question, and you are looking at a randomly drawn sample, and we talk about successes of the things that you are expecting to occur, And the other part, which is not success, is what won't occur. So now let's look at the distribution characteristics. I'm sure, again, your lecturers have done this with you, but you're seeing something that is observed n times. So n is a sample. So it's discrete. They're discrete variables that do something. So 1 out of 4 go and shop on this website. Okay, so you have observed it. They are mutually exclusive. So in other words, class, for instance, if 25% of people make a purchase of 500 Rand or more, then quite simply 75% of people do not make a purchase of 500 Rand or more. It's a mutually exclusive and a binary option. In other words, it either is or it isn't. The success is when it happens, not the failure, but the alternative is when it doesn't happen. Okay. Collectively exhaustive class means that you are looking at a closed event space where this is happening, and that has an important implication a little bit later. Each outcome has an associated probability. So in the example I've shown you, in the example I'm going to go through very slowly with you, they're going to say 1 out of 4 people do something. That is a probability. It's 1 over 4, class. It's 25%. It's 0.25. That is an associated probability of a success of something happening. So 21 out of 4 people make a purchase on a website. 25% of people out of that random sample make a purchase on a website. Therefore, class, 1 minus 25% don't make it. So that is your 1 minus P for the so-called failure of it. Now, it's not success and failure in the normal English language terms. It just means it either happens or it doesn't happen. Okay. And then there's an independence rule. We're not too worried about that at this stage. Right, so the first thing is, class, and this will be given to you on your formula sheet, you've got to get used to looking at the binomial formula. Now, there are not 4 issues, but there are 4 variables you need to be aware of. This first section of the binomial formula is your combinations formula. Now, remember, students, that is not given to you in your formula sheet. It is part of the probability of the previous question. So you must know how that actually, or what that actually looks like. And so that your combinations formula deconstructs into n factorial, x factorial, n minus x. So this here is that there, okay? They don't give you this, they give you this. So you got to know that actually deconstructs to that. That's the first thing. So that's your combinations. Then that little dot is multiplication. Then you go to px. That's the probability of success. So that is in my example that I've just used. That is your 0. That's your probability of your 0.25. Okay, let's assume. And then let's assume this is the number. Let's say they want to know if one person, the question is, what is the probability one person will make a purchase? That would be your x. Okay. Then we move to your last term here is 1 minus p. So that would be the probability, if I can use the word failure. So if this is 0.25, that's going to be 0.75. If this is 0.2, that's going to be 0.8. Okay, so it's going to be the complement. Those two are complement. They must sum to 1. And the n is the full random sample of however many were taken. So n minus x. Let's say they took 12 people. That n will be 12. That x will be the number of ones that you're looking for. So if they say to you 1 person, that's what the x will be, as 1, etc. Now remember, this is a discrete probability distribution. So class, depending on the question, you are going to have to add up the number of probabilities that they are looking for. So here is an ideal exam type question. It's going to look very much like this, class. So they're going to say something along the lines, it has been found that 1 out of 4 people who visit a local supermarket purchase bread. If we randomly select a sample of 9 visitors to the store, what is the probability? Right. Okay, before we move at all, immediately you know and understand that that's a binomial type question. Why? What are the characteristics? Well, first of all, they have told you the probability of a success, 1 out of 4, or 25%. Who visit a local supermarket, purchase bread. Then comes N, the big number. If we randomly select a sample of 9 visitors to the store, what is the probability? So now you've got your P, you've got 1 minus P, and you've got your big number N. Now, X is dependent upon this section of the question. Here they're saying no more than 2. And class, quite honestly, this is very much what they give you, okay? Or I can't say always, but 90% of the time they'll say no more than 2 visitors, okay? Now, what are they saying there? They're saying that in the question, 0 visitor, because no more than 2 visitors is no visitors make a purchase, 1 visitor makes a purchase, or 2 people make a purchase, okay? So because it's a discrete probability distribution, you are going to need to calculate the answer for 0 people making a purchase, then calculate the probability of 1 person making the purchase, and then calculate the probability of 2 people making a purchase. Why only 0, 1, and 2? Because that's what the question's asking you. No more than 2. If it said no more than 3 class, then you would do 0, 1, 2, and 3. If it said only 1, then you would only do 1. So this is why this is why it falls under discrete probability distributions. Right, so we've got the initial data. 1 out of 4 is our P. Therefore, 1 minus P, so 1 out of 4 is 25. So 1 minus P must be 75. That's your N, and your X is going to be 0, then 1, then 2, and you're going to add them all up because they're discrete. So now we're going to see how we work this. So the first thing you do in your exam paper is you're going to, not that you'll get marks for it because they give you that, is you write down your binomial calculation, all right? I mean formula straight away. So you know what you're doing with it. Then my suggestion is write down what they've given you. So they've given you N, which is 9, because there were 9 people in the sample. They've given you P, 0.25, because it was 1 out of 4. And therefore, you know that 1 minus P, okay, that should be the other way around, is 0.75. Okay, right. Now we've got all the bits and pieces we can plug into this and that and that. Right, don't worry so much about the statsy bit. This is just saying I'm going to add 0 people to 1 person to 2 people to be able to get me my total number. That's the way I'm going to have to work this. So this is the calculation for 0 people. Okay, I'm going to take my X, which is 0 people, and I'm going to put it into all of wherever I see, well, in this situation, it's either R or X, and I'm going to place it into my where my R is. So there would be X would be 0 factorial. Okay, 0 factorial. Why 0? Because I'm starting with 0. Then the next one I'm going to put a 1 in there, and then the next one I'm going to put a 2 in there. Okay, let's do the 0 first. So we put a 0 there. N minus 0 will be N is what's N is 9. So it'll be 0 factorial 9 minus 0 factorial over n factorial. Now, all of you now, hopefully your lecturers have shown you how to do this on your calculator. So your Casio will do this extraordinarily easily if you put it into your maths mode and you just plug it in. Class, I suggest if you don't know how to do it properly, now is the time to go and find out from your lecturer exactly how to do this calculation, but I'm sure they've told you. And then you let the calculator do the calculation for you. You don't have to sit and sweat all these factorials. Remember, 0 factorial is not 0. 0 factorial is 1. Why is it a 0? Because we're starting with 0 people. Then we move down and say, fine, what about the first person? Because remember what the question is? No more than 2. So that's 0 people, 1 person, and 2 people. Okay, so now we're doing 1 person, finding the probability of 1 person, okay? There's the probability of no people. So now we, instead of having a 0 there, we put a 1 there. Okay, and then n minus 1, which will be there for 8, when 9 will be on the top. That will be a 1. Sorry, that'll be 0.25. That'll be a 1. That'll be 0.75. That'll be a 1. Work it out, and you're going to get to 0.2253. And by the way, class, you'll see that after this, I'm going to load, this will be loaded onto your Masterclass site along with all the slides. So don't worry about trying to get the slides now or take pictures of it or whatever. The slides will be available straight away. So just rather perhaps listen to how this thing plays out. Okay, then it's no more than 2. So you still have to do the second one, because no more than 2 implies 0 plus 1 plus 2. So you go and get, now it's x is equal to 2. You put a 2 in there. You put a 2 in there. You put that 0.725. There's a 2. That's 0.75. There's a 2. And there's an n. And then you do that calculation and you get 2.3 or 30%. So you got 30% there, 22% there crudely, and 7% there. Now, class, because they are discrete, you've got to add them up, because they are discrete individual probabilities. You can't just leave them like that. So you're going to take this, this, and this, and add it up to get to 60.07. So your binomial is a class of question that deals with either a success, the people who've bought bread, or the people who didn't. So if 25% of people bought bread, 75% of people who visited that supermarket didn't. That's a success or a failure. You're going to be given a sample size. It's collectively exhaustive. And collectively exhaustive means, class, that all the probabilities must sum to 1. So quite simply, if they had said, what is the probability of more than 2, then quite simply what you would do is you would take this number and minus it from 1, because it's a collectively exhaustive event. Right, and then you would know and understand that they're going to give you that in the formula sheet, but they ain't going to give you this. Now, remember, the R and the X are interchangeable. Some formula some formula use X, some use R. Class, remember the difference between a combination and a permutation formula. When it's got a C there, it's a combination. When it's got a P there, it's a permutation. When it's got a C, class, you use this formula. When it's a P, which means there has to be a form of order, you take away the R or the X factorial. Learn those formulae. They're not given to you. Right, now so we said at the beginning, this will be a section C, second type question. So they will either give you a binomial or a Poisson. My thinking generally is that they give you binomials. So if you're going this route, get to grips with your binomial, but don't discard the fact that they could also ask you a Poisson. Now, this is a totally different type of question for a totally different class of statistical cases. And in this situation, you're just looking at the problem. It's actually a much quicker calculation, because you're only really dealing with 2 types of variables here. Whereas with binomial, you've got a whole bunch of variables you have to deal with. So if you do get this and you've gone this route, then actually you're quite lucky in a way. So the type of question that they're going to ask you is, what's the probability of X, something, occurring over a given outcome? So something occurring, the number of breakdowns over a period, the number of calls coming into a call center over a period, the number of admissions in a hospital over a period. I'm pretty sure you get the drift. Whereas a binomial is 25% of people do this, 75% of people don't do this. Binomial, success or failure. Poisson, as I said, number of breakdowns over a period, etc. So something over a period, or a space, or a volume. It doesn't have to be over a period. In other words, over a time period. Class, it can be the number of mistakes over 3 meters of cloth in a printing press. But it'll always have a measurement element, and there is no success or failure, or 2 types of, they're not going to give you 1 out of 4. That's the key thing here. If you can remember that a binomial has the wording 1 out of something, and this one doesn't. Okay, so As I said, number of breakdowns, etc., occurrences. I'm not going to worry too much about the theory. That's the strange looking calculation formula that you're going to get, but it's actually very simple. E is your natural exponent or your log. On your calculator, you'll find a little E somewhere on your Casio. The upside down, I'm just going to call upside down U because that's exactly what it looks like. I'm not going to use the clever names here. And it's minus. And then you've got the upside down U, and you've got an X and X on the bottom. There we go. That's it. They give you this so you don't have to worry about it. Now, why is it a discrete probability distribution? Because you're going to do discrete. You're going to do it discretely. In other words, for each of the people you need to do it for. So if they say one person or two people or more than two or less than two or whatever, probably be less than, you're going to add them up, 0, 1, and 2. You can never have minus here, class. That X can never be a minus. You can't have minus people. It'll always start at 0 and move up. Okay, so now the easy thing about this is that the upside down U is given to you. That's the average. Mean is the average. And X is just going to be 0, 1, and 2. E is it's a program. It's programmed into your calculator. You don't have to remember any of the names. I mean the numbers. So in a situation like this, let's have a look. And it said it has been found that on average 5 cars use a service station in a period of time. Now they give you this 15 minutes. Don't do anything with it. They're just telling you it's over a period of time. So for you, that 15 minutes is neither here nor there. It's just they're providing it to you over a period of time. And there's a special case when it will be used, but I'm not going to worry about that at this stage. So the most important points here that you get out of this type of question is the number of discrete variables that happen over that period. And it could be breakdowns. It could be cars visiting a petrol station. It could be the number of calls, okay? They are discrete, the number of people making a call, etc. So now you're going to take your formula that we saw on the previous page, and all you're going to do is that 5 students is going to be your upside down U. Okay, that's all it is. That 5 is your upside down U, and the X is the number of occurrences that you need. So it's pretty simple as that. So they're asking you on average 5. So immediately you plug into your calculator. There's your E. That's minus 5, class, because it was minus here. And then you've got your 5 there to the power of 0, which hopefully you all know is 1. All over 0 factorial. Why 0 factorial? Well, because that you're starting with 0 people. And it's again the same type of question as your binomial. No more than 2 cars. Well, that class is 0 cars, 1 car, or 2 cars. So again, you're using the same process here as a binomial because these are discrete probability distributions. The calculation is entirely different, but the process in terms of the question is the same. So if they say no more than 2, ask yourself, can I have minus cars? No, I can't. So I'm going to start at 0, and no more than 2 means, hey, no more than 2 cars. So that's 0, 1, and 2 cars. Okay, so then for each one of those cars, you are going to do a separate calculation. So you're going to have 0 for 0 cars, 1 for 1 car, 2 for 2 cars. And again, using the same process as binomial, you're going to add these things up and get to a final probability, which is 12.46. Always remember, for both of these types of questions, both binomial and Poisson class, please remember to convert them into a percent at the end of the day. Please, it's very, very important to do that. Right, okay, let's move on. This is now an important section, and it's an important section for one simple reason. You are going to use what you've learned here through into hypothesis testing. So even though you may be in section C and you are not going to answer a binomial or a Poisson or one of these questions, the process is actually very important to know for your hypothesis testing. Okay, when we get to hypothesis testing, that's the important area that you need to know and adopt these procedures. So the first thing you need to remember, class, at this stage is that you are going to be using is something called a standard normal curve. And a standard normal curve, class, is one of your bell curves. Okay, let's see. I haven't got a... Here we are. So we have a standard normal bell curve. Now, you are going to use a process, all right? And the process is as follows. And then I'm going to take you very slowly through an exam type question. All right. So the data that you're going to use is going to be different. So the key word they are going to tell you is that the data is normally distributed. It is normally distributed, class, because it is not discrete data. It is continuous data, and therefore it's continuous data, which means there are no breaks in the data stream. In other words, you can have one car or two cars. You can't have 1.5 cars. In terms of temperature, you can have 11.2 degrees centigrade. You can have 11.25 degrees centigrade. You can have an infinite number of points between 11 and 12 degrees. That is why it's continuous. There are no breaks. Okay, so the first thing to remind yourself is that there is a process. I teach this to my students, and it's a very nice, easy rule of thumb way when you are dealing with the kinds of questions we're going to start looking at. So you are using a standard normal curve to find a probability, okay? In your discrete probability distributions, class, you used a formula. You didn't use a table, okay? The tables at the back of your book, which are your Z, your T, and your chi even, which is not a standard normal, are used when it's continuous data. When it is binomial or Poisson, you do the actual calculation yourself. You don't use a table. So in these questions with a normally distributed curve, you are going to use a table. All right. Now, the table you're going to use is called the Z table to start with. And in hypothesis, we're going to then also use something called a T table. So the first thing you're going to do in process terms, and then I'm going to show you very slowly how the thing pans out, is you take an X value, and you convert it to your Z value by using your standardization formula. Once you've done that, you've got a number, and you'll see it says Z equals. Now, the Z equals means you've converted it, and you can go to a table to look at it. Take the Z value and find the probability, because in your Z table, class, you will be able to read off your probabilities, okay, from your Z table. That's the crucial issue. You will get a Z table in the exam, and even if you don't use it here, which is your section C, you go on to hypothesis testing, you're going to use, well, you'll probably use either your Z or your T table. So it's probably not a bad idea to kind of get used to the idea now. Right, so let's have a look at an example. It's no use really looking at the theory without looking at an example. So here's an exam type question in section C using continuous probability distribution. All right, so let's have a look. So the score obtained on an IQ test is normally distributed with an average score of 115 and standard deviation of 9.5. So class, if you are still unsure about how to differentiate between discrete and continuous, the clue is the fact that they will tell you it is normally distributed. Being normally distributed means it has a continuous probability curve, okay, with an average score of 115. So they have to give you the normally distributed bit, they have to tell you the average, and then they have to tell you the standard deviation as well. Why do they have to tell you all of those things? Because, class, in your formulae, you will see that is your mean. So that's mu. That stands for mean from the question. That's your sigma, and that's your standard deviation. And your x is the thing you're looking for. So let's have a look what we mean by that. So in this situation here, we've got an average. That's your mu value, okay? And your standard deviation, which is your sigma, which goes on the bottom. Right, so you got those two. Now the x you have to work out from the question. So now they're saying to you, what is the probability that a randomly selected person will obtain a score between 110 and 118? Right, so this is where we get to town with our standard normal curve. There's your standard normal curve, class. What are they asking you? They're asking you to find the probability between that there, which is 110, and that there, which is 118, I think the number was. So they want the probability between those two. Now, this is the power of a probability curve like this. You don't have to go and calculate it out yourself. All you need to do, and this is the important part, is do two calculations. One, because let's go back, let's see what they're asking for, 110 and 118. Okay, so you're going to take your 110 and stick it into your, so 110 minus 115 divided by sigma. And the next one is 118 minus 115 divided by sigma. So you're going to do two calculations to get two Z values, okay? Those Z values are going to help you find your probability. So the first thing you've done is that's your, you've taken your X and you've converted it to a Z value, right? You've taken your X, you've converted it to a Z value. Now it says a minus there. In terms of your table, you can drop the minus, okay? The minus is only showing you the direction, which side of the mean it lies, because both sides of these curves are fully symmetric. You don't have to worry about that being that minus 0.53 being different from that one, okay? I mean, in difference from this side. They're both symmetric around the mean. So now the most important thing you've got now are two numbers, okay? And those two numbers are Z numbers. That's a Z number, 0.32. This is a Z number, 0.53. Now your next question, and your last question really, is to say, well, what the hell do I do with these Z numbers? And this class is where you go to your Z table. So you are given a Z table. And on the far left side of your Z table, you'll see right at the top, it says Z table. And then you take your first number. Okay, you don't take them both together. You go 0.3. And then you run your eye down until you get to 0.3. Then you run your eye along till you get to 0.02. All right. So you're going to use your Z table here. The first big number is the first big number on the extreme left of your Z table. The next number is the one you run along the top. My suggestion is if you have a third number here, which is 5, class, quite simply just roll it up to, so if this was 0.325, let's pretend that it isn't, then just roll up that 2 to a 3. Okay, so just because you don't have, on your Z table, you don't then have another additional area to look for. So with these numbers here, just make sure you got 2 of them. That's your main number that you run down with. And this number here is the one which runs along the top. Similarly, but you're going to drop your minus, it's 0.53. So you're going to go all the way down to 0.5 class, move along to 0.03 and read off that number there. That number you read off your Z table is a probability. So the number on 0.32 is 0.1255, and this number here links to 0.2019. And don't try it now, or if you haven't got your book with you, it's not a problem. But when you have a chance, class, get your book or your table, whatever your lecturer has given you out in class. I think it's even in your study material, and try it out. Get those numbers. Okay, well, these numbers you just calculate, but get this number converted to that number through your Z table. Get this number converted to that number through your Z table. Once you've done that, class, you've got probabilities. So the Z table kind of magically is going to convert your Z number, which is a standardized number, to a probability. Now the question, that's fine. So you got these two numbers. Now what are you going to do with them? Look what the question is asking. What is the probability that a randomly selected person will obtain a score between 110 and 118? That's the question. So they're asking you here, what's the probability between that number and that number? Okay, so you've got the probability there, and you've got a probability there. The probability here, this one here, 0.32, is from your mean to that point. And the probability here is from that point to the mean, or the other way around. So logically, if you've got a number from there to there, and you've got a probability from there to there, and you need to know the full probability over that space, then class, you add those probabilities. Okay, you add them if they're on either side of the mean. I'm giving you a rule of thumb now. So if they give you a question that says a selected person will obtain a score between 110 and 118, 110 is on one side of the mean's 115, hey? And the 118 is on the other side. So if you have two numbers, one on each side of the mean, class, you add those probabilities. Okay, this is very important, because if you get them round the wrong way, or you start subtracting it or stuff, you can get the wrong answer. Now, I just want to show you something. Okay, I'm just going to go back there. And I'm going to stay on this just for a little bit longer. Now, let's assume, and I'm not going to do the full calc, I just want you to understand the process. They said to you, what is the probability that a randomly selected person will obtain a score, not between 110 and 118, but they say to you between 116 and 118. Now we have a different type of question. There's your mean, which is 115. Okay, now we've got a question with both of those numbers being on one side. Whereas in this question here, there was one on one side of the mean and one on the other side of the mean. In this question that I've just asked you hypothetically, what's the probability between 116 and 118? They are on both sides of the mean, the same side. Okay, let's put it like that. And in that case, class, second rule of thumb, if your probabilities to find are on the same side of the mean, then you subtract them. If they're on either side of the mean, you add them. Okay, so let's say that again slowly, because that'll help you if you get this question. If you have a question and the one probability is left of the mean and the one probability is right of the mean, like here, you add the probabilities you get from the Z table. If you have a question where both probabilities are on one side of the mean, like 115 and 120, 116 and 120, then you subtract the big one from the small one, okay? Because they're on the same side of that mean. That's a rule of thumb, class, that if you get confused, just apply it. Say, where are those numbers? Are they on either side of the mean, or are they on the same side of the mean? If they're on the same side of the mean, subtract them and you'll be fine. Okay, so remember that when you're doing it. Now remember where we are in context. We're in section C. We're in that second question that you would be answering. The first question would be probability trees, frequency tables, those sort of things. Again, class, the way that the exam is structured, I'm saying to you now as students, start deciding what type of questions you want to ask yourself. Okay, so I'm sure your lecturer's gone through an exam paper with you, or it's given you exam type questions, okay? And you now know at this stage, and I'm going to end all of this off by going back and looking again at the exam question paper in the way it's structured. You ask yourself where you are better. What do you understand more? Do you understand frequency tables? Do you understand probability trees? Then answer the first question in section C. If you know this stuff better, if you feel more comfortable with continuous probability distributions, you happy with binomial, then answer the second one. But don't answer both of them, because if you answer both of them, markers can only mark the first question that you answer. Okay, I know that the exam is still about 2 or 3 weeks away, whenever it is. But class, start now. I know you got a lot of other stuff on your plates, but start now saying to yourself, what do you feel more comfortable in stats with? Okay, and then make sure that you're comfortable with answering those questions. Now, the final type of question in section C, second question, will be a sampling distribution question. Now, this is nothing more different than the continuous question that we've just done, except instead, class, there's one extra element that you must be aware of. Okay, so it's exactly the same as a continuous probability distribution. That's why they are so important to know. But the difference between this and the previous question is the following. okay? You're going to have two types of formulae, a sample mean and a sample proportion. And the reason this is so important is because we're now starting to move towards the way you are calculating in hypothesis testing, okay? We're starting to move towards the way that you are calculating in hypothesis testing, which is section D. Okay, so sampling distributions take their name from the word. They are samples from a larger population. So you have to apply a slightly different formula to take into account something called a standard error, which is because it's not the full population. So you may see this formula here, and you'll say, I've just seen that. There's an X, there's a mu, there's a sigma. And that's all it was. So let me go back and just show you the difference. Be aware of this difference. That's for basically a calculation of a population, all right? This one, class, is different because it is dealing with a sample. So the difference is there's another bit at the bottom here, which is division by the square root of the sample. Don't worry yourself about why or how, just remember this. Now, this formula and this formula are given to you in your formula sheets. So you don't need to learn them. But what you do need to do, class, is know the type of question which goes with each one. Because if you get this right at this stage, then hypothesis testing will be a lot easier for you to understand. Because this is a good precursor to hypothesis testing. Okay, so let's take an example from one of these, straight out of before I move on, and you can say to me, well, what the hell's the difference between this and that one? Okay, what's the difference between a sample proportion and a sample mean? Okay, class, write this down if you've got anything in front of you. I can give you the big, clever statistical thing, or I can tell you something that you can perhaps remember and use efficiently. A sample mean will use a number in the way that the question will contain a number. Okay, now you're going to probably say, yeah, well, they all contain numbers. They all don't contain that kind of a number. So this could say there's 150 avocados in an orchard. Take a sample of 90. Those are numbers, class. They are numbers of things. They are therefore you use a sample mean. On this side of the breakdown, you have something called a sample proportion. You are dealing with categorical data. The question will not have numbers, it'll have percents, because you are using percentages of categorical data. So percents here, numbers there. If there is a percent in the question, it's a proportion. If it has a number in the question, it is a sample mean. And this and that are exactly the same that you're going to take forward into hypothesis testing. All right, so next thing to learn. Class Act PDY Limiters found that 35% of its policyholders are below the age of 30. Immediately, class, before you even think, and I think I may even have it here, you don't know, the rule is 35%. Is a proportion type question. This thing here, going back to your flow chart, that thing there, that means percent. This means mean. Okay, right, so it's got a percent in the question, therefore you're going to use a sample proportion. Generally, they break the question down into three components. They'll say determine the standard error. Now, class, the standard error for both of those calculations is the thing on the bottom, the denominator. So that's the standard error calculation. This is a standard error calculation. They're not asking you to do anything different because you'd have to do them anyway, but all they're doing is helping you in a way by getting you to do parts of the question to start with. So determine the standard error for the sample. So we take the bit at the bottom and we calculate it, okay? So this is the bit at the bottom, okay? And and the last thing we need to understand, sorry, something I did leave out, which we need to go back to, is let's go back and have a look at this. There's a P and there's a pi. First of all, class, make another mental note. I had a student the other day doing exactly the thing I'm about to tell you to do now. The pi that you see in front of you is not the pi that you used in geometry. It is not to do with the circumferences of circles. It just happens to be a symbol that they use. You're not going to use the number pi. Please remember that. It's just a symbol. So pi is what is given to you. So pi is 0.35. Also, again, remember, you're not going to put 35% in. You're going to decimalize it to 0.35. Okay, that's really, really important. Okay, it's going to show you something here. Right. So we are doing the standard error. So they're going to say determine the standard error for the sample. The standard error is the bottom part of the formula. Okay, so now we've got a whole bunch of things we can stick into it. We know that pi is what they've given you, okay? Pi is what they've given you, and it's been made into a decimal. So 0.35, 0.35, open bracket, 1 minus 0.35, close bracket, exactly like you've got in the formula, divided by the size of the sample. 145. Do the calc on your calculator, you get to 0.04. Now you got the bottom bit, okay? You got the bottom bit of the formula. That's the standard error. And the standard error is the number of errors from the mean. We don't need to worry too much about that. We need to get the numbers right. Now, the next thing, what is the probability that more than 34% of the customers in the sample are below the age of 30? That's your P. That is your pi. The question is your P, okay? The pi is what they've given you. The P is what you find. Okay, so now we've got the bottom bit that we've just worked out. Now we only have to stick the bit on in the top, which is 0.34, which is the thing they found, and 0.35, which is the thing they gave you. Okay, and you work that out and you come to minus 0.25. Now again, class, you now need to take that number and you take it to your Z table. You're going to remove the minus. You're going to go all the way down 0.2, all the way along to 0.05, and find the probability there. Okay. All right. Now we are going to, as I've said, and I'm showing you here, you've got that, and you're looking now the probability all the way through. So you've standardized that number. All right, you've standardized it because it came out the calculation there. It came out the calculation there. And you said, what is the probability that more than 34% of the customers in the sample are below the age of 30? Right, so you've got the probability, 0.025 when we get it from there to there, but that's not what the question asked. It also right the way to the end of the curve. Now, remember again, class, I keep giving you rules of thumb, but it's quite important that each half of the curve is 0.5 or 50%. Each half of the curve is 50%. Together they add to 1. Okay, that kind of makes sense. So what we have here, class, is a situation. You've got the 50% there, and you've got the calculation 0.25, which you are now going to convert. Now the 0.25, that's your Z value, okay, you got from your calculation. If you were to go to your Z table, and if you have one with you, great. If you're going back, revising from these slides, please remember, and as I'm teaching it to you, you go to your Z table, you go down and you get to 0.2, 0.2, and then you go all the way along to 0.05, and you'll find that's your probability, 0.0987. But now we've added a 0.5 on. Why the hell have we done that, do you think? Well, we've added on this section of the curve because the question is, what is the probability then more than 34%? So 34% is here, and more than 34% is the rest of the curve. So you've got the probability of 9% from there to there, but that's not asked. They're not just saying to the mean, they're actually saying the rest of the curve. So you've got to add on this whole 50%. By doing that, then you can find it out, and you're going to say, well, hey ho, there's my probability, which I've just worked out. I've converted that Z to a probability. That Z, remember class, is the following. It's your probability from there to there, okay? It's a probability from there to there, but that's not what the question asked. The question asked the whole thing. So now you add the 50% on. If they ask you something all the way from a point to the end, of course it's infinite, eh? Because this thing never really, although it looks like it is here, it does not touch your x-axis. It continues to infinity, positive and negative infinity there. But for us, that gets so small it doesn't really matter. This part here is 0.5, that part there is 0.5. So if you have the probability here to there, which is your 9%, add on the 50 and you get your final answer. Now it's quite important because we're going to look at that a little bit later in hypothesis testing. So the probability that more than 34% of the customers are below the age of 30, therefore is 59.87. Now class, it's very difficult in the space of about 1 or 2 hours to completely cover this exactly and comprehensively. All I'm really trying to do is kind of notch up where your lecturers where their lectures are done and have taught you, and then just add it up for areas that you don't understand. But I'm really strongly suggesting that when this becomes downloadable, which will be later today, okay, take it, download it. And use it with your lecturer's notes and that for revision, because you must get into the hang of looking for the numbers like 0.25 on your Z table. Go there, find it, find out how to get that number. Do this calc in front of yourself. Do it with your mates or whatever, so that when you walk into that exam, you feel comfortable. There are far too many students, class, who, although they do well in stats, could do better because they're not comfortable in what they're doing in the calculations they're doing, or just looking for numbers in Z tables, etc. So please just do that when you have a chance. All right, so that's your sampling distribution. Now, and that was one example. The other was a sample mean, which would be exactly the same process. Now, this is where I'm going to spend a lot more of my time again, because I know this is also towards the end of semester. Most of you now have completed stats, I would think, completely. So you're probably on learning break now for exams. Hypothesis testing and chi tests are stuck right at the end of the semester, when a lot of you are doing POEs and you're just already a bit full of the whole thing. So what I'm going to do is I'm going to go through the thing again with you. I'm giving you a series of rules. They're in your book, but I'm kind of making them kind of quick and easy to learn. I'm going to show you exactly the kinds of questions that they can ask you, and I'm going to show you how to do it. And just take it. As I said, I can't teach you hypothesis testing in 3 hours from zero, but what I can do, and I hope to do today, is at least wherever you have a little bit of not quite sure, that's where we're going to kind of polyfiller it in. Okay. So the first thing you guys are going to do, and I'm going to give you the flow chart that I give my own students, and it really helps him because it cuts out a lot of, well, what the hell should I be doing here? Immediately it defines and it helps you exactly take the correct route. Okay, so your first big top question is, are you using, as I said to you in the sampling distribution, are you using a number or are you using a percent? If you're using a number class, you're going to be using a population mean, okay? Because what really are you doing in hypothesis testing? Let's cut out all the other stuff, but for us in this course we're doing, what is it? What is hypothesis testing in plain English? It's somebody makes a claim and you test it. Okay, that's all it really is. So if I come along to you and I say, I've just invented, or I've just made a brand new SUV tire, last 65,000 kilometers. Class, that's my claim. And you can come along to me and say, well, then prove it. So I have to prove that claim. So I say, find my average. Let's say I'm saying an SUV tire lasts 65,000 Ks. Right, so what do? I go out and I go and randomly sample people who have bought my tires, and I get that average. Okay, I get the average that they've got, so I get the actual against my claim, and then I put it through exactly what we're going to do now, and it'll either come out yes or no. Either I accept the null, which is yes, hey ho, my claim is true, or I reject the null, and then I'm saying, hey ho, my claim isn't true. Okay, that's basically what hypothesis testing is. There's a lot of other bells and whistles and clever things lecturers can tell you, which is great. But if you don't kind of know from the base what you're trying to do, it's not really helpful. So you're testing a claim, and you're testing a claim either around a population mean, or you're testing a claim around a population proportion. If it's a mean class, it has numbers. If it's a proportion class, it has a percent. Remember that from your previous sampling distribution. That's why I'm saying it's so important. Right, so we get that sorted out. Next thing, here's my famous kind of flowcharty thing, which I find really, really helps. Look, you can't take it to the exam or anything, but it jolly well can help you understand which way to go. All right, so you start at the top here. Right, that's who you start with the question. Sensibly, and the question is either going to be a question on categorical data, or it's going to be a question on numbers. Okay, so it's either a percent or it's got numbers. If it's got numbers class, it'll either be a Z or a T test. If it's got a proportion, okay, if it's got a percent, it uses the different formula, and you're going to still use a Z table. Okay, so Z table here and Z or T here. But there's a difference. Okay, here these are numbers, there's a percent. You use this with a percent, you use those two with numbers. Population mean, population proportion. Done. Right. So you start here and say, right, what am I doing? Am I dealing with a percent or am I dealing with numbers? If you know you're dealing with a percent, you go straight down there. If you know you're dealing with numbers, you have one further question to ask yourself. Okay, there's a lot of other stuff you can ask yourself. I'm telling you the one and the easiest way to do it is to say, what is the size of my sample? They have to give it to you in the question. So you know you're dealing with a number, and then you see that the sample's like 25 months. It's because it's generally in months. So 25 months, right? Then it's a t-test, straight. Don't question, done. If the sample is like 65 or 80, then it's a z-test, done. Now, what is the cutoff? And the cutoff I'm giving you, class, is if my sample size is larger than 40, okay? My sample size is larger than 40, I use a z-test. My sample size is less than 40, I use a t-test. And generally, they're not going to give you 38 or 41 in the sample. They probably, if they give you a Z, it'll be like 65 or 70. And if they give you a T, it'll be like around about 19 or 20. So you'll know exactly. So you come trundling into the question. Has it got a percent? Okay, I go that way and down there. Has it got numbers in? Hey, I go this side. But right, what's the size of the sample? Size of the sample will determine whether I do a Z or I do a T. It's as simple as that, really, honestly. It's not much more difficult than that. Right, once you've determined what side you're going, then you stick your process in place. Now, the process, class, there's 5 of them. There's 5 sessions, there's 5 steps in your book. Great, lekker. But you can actually make the step 4 and 5, me personally, into one, okay? As long as you put all the elements in that you need to, okay? That's important. So you're going to define the null and alternative. We're going to do all one. Don't worry. I'm just giving you the process now. And you probably, I'm pretty sure your lecturers have taught you this. 2, determine the region of acceptance. 3, calculate a test stat. Again, say to yourself, what the hell am I doing? It's no use learning this without knowing context. So the next thing you need to know, students, is, okay, my lecturer told me I'm testing a claim. Great, I'm sorted. But what the hell is this process? How do I test this thing? What am I supposed to do? Because there's no use charging off without knowing what you're supposed to be doing. So the first thing is, class, you have got this claim. And you either accept the claim or you reject the claim. So you've got to define the claim. You define the claim in step 1 by saying my null hypothesis is the claim is true, or in this, not so much chi-test, we'll come to chi-test in a minute, or, hey ho, my alternative is the claim isn't true. Remember, I made a claim, I've got to test it. So logically, it's either true or not true. It can't be half true. You can't have half true claims, okay? Right, that's number 1. So you're done and dusted with that. Number 2, you've got to test it within a region of confidence. So the 3 confidence levels they're going to give you are going to be So no, let's call it significance because that's more the way they give it to you. So either 1% level of significance, 5 or 10% level of significance. Okay, that will be in the question. So you'll only get 3, 1, 5, and 10. All right. We're going to work out finding. So what you're saying is eventually is either my null is true within a 95, 99, or 90% level of confidence, or it isn't. Okay, that's what you're saying. And then step three is actually finding where the number is. Is it within the bounds of confidence, or does it lie outside the bounds of confidence? So you've got a claim, you test in step 1. In number 2, you put the bounds in that you are going to put step 3's number in. Step 3's number falls between step 2's number. Hey ho, you are going to accept the null. If step 3's number doesn't fall in the 2 bounds of step 2's number, you reject the claim. Class, that's it. And then in step 4 and 5, you just summarize and say, hey ho, I accept the claim or I reject the claim, and say that it's probably false or probably true. It's as simple as that. Honestly, you can get 10 marks for one of these things in half a paper, half a page of your exam book. And if you know what to do and where to put the marks, which I'm going to teach you now to build your mark base, even if you make a stuff up somewhere, you can get easy 4 or 5 marks out of this. Okay, so we're going to go on the mark building exercise now. Right, so let's do exam type question. First of all, I'm going to give you a question that's got numbers in it, and then I'm going to give you a question that's got percentages in it. Okay, and we're going to do a proportion, and we're going to do a sample mean. This one, class, is a sample mean. Why is it a sample mean? Well, quite simply, it's got numbers in it. Okay, so with numbers in it, class, it means it is a sample mean. It doesn't have any percent. The only percent it has is your level of significance. And okay, that's not anything to do with a proportion or a mean. So a sample random of 10 people from a certain population has a mean age of 27. The manager of the project claims that the mean age is 30. Right, immediately, class, first, there's a couple of things you do. You go back to my little kind of flowcharty thing here, and you say to yourself, right, okay, it's a numbers thing. Great. I go this side. If it's a proportion-y thing or a percentage, I go this side. It's not a percent. There's no percents there. This is a numbers. Right, I go this side. Now, my next question is, what is my sample size? Now, my sample size, oh, goodness, what was it actually, if I remember, is 10 people. That's quite a small sample. Right, go back here. Is my sample larger than 40 or less than 40? No, it's patently less than 40. It's 10 people. So I'm doing a t-test because I do a t-test when my population is less than 40. And secondly, I don't know my population standard deviation, but rather use the size of the sample as an initial test. Right, now we're sorted. Now we're good to go. We can slap in our steps and get the thing done very quickly. You've given all the information you need. There's the sample, which made you go down the t-test. Well, first of all, there's numbers. That makes you go down to a sample mean. Then you see that there's a sample of 10 people. That means it's a t-test. Now you know exactly where you are on that spreadsheet. The last thing you need to do is test it at a particular level of significance for your step 2. So now we just whack this in. Right, done. Here we go. We know where we're going. We're going down the correct road. Okay, first of all, step 1. What is the claim? What's the oak saying? Well, he's saying that the mean age is 30, or the average age is 30. So then, logically, the null hypothesis is the claim is correct. It's 30. But what I'm asking you to do, Bright Sparks, as well, is do it correctly. Write this down the way I've got it here, because that's where you get your marks, is by putting it correctly, putting it in proper statsy speak. And that's statsy speak, and this is statsy speak for saying, no, it isn't true. And that's your alternative, and that is your null. Now put that down, and your lecturer will, well, depending on what the memo says, will give you 2 marks. Now you're building your mark base as well. So even if you make a stuff up later, and it can happen, I promise you, class, I've made stuff ups on these. So this is not me being clever. But what I am trying to do is get you to make sure that you build your mark base properly. So you go in, you start this question, you put step 1 down, so your lecturer knows where you are. Put your null, put your alternative down. And that's it. And if you want to really impress your lecturer, you say the null will be rejected if sample evidence shows that the values are either higher or lower than 30. But you know what? Let's get the basics done. Now we go to step 2. There's step 2, right? Remember, step 2 was determining your level of your boundaries, your critical area. Because remember what we're trying to do? We're going to get a number from step 3 that either falls within those boundaries or falls outside the boundaries. If the number falls within the boundaries, we accept the null. If the number falls outside the boundaries, we reject the null. What are the boundaries? The boundaries are the level of confidence that they've given you. Okay. Now, because this is a t-test class, you don't go to a Z table. Okay. Now, I know that it sounds silly for me to say it, but the number of times I've seen students trying to use a t-test with a Z table. So you use your t table. Now, your t table looks different from your Z table. Your Z table, all you do is have your Z standardized number and you go rooting around for your proportion. Class, with a t-test, you've got 2 additional pieces of calculation that you must carry out. So in step 2, this is important. Please remember this to build your mark base. First of all, put down what they've given you. Okay. They have given you the information that you need. So from the question, let's go to the question again and see what it says. Test the claim at the 5% level of significance that the mean age of the population is 30. Now, most of you, and I'm sure your lecturers have taught you, that if you're testing to a number, it's a two-tailed test. It doesn't say greater than or less than. And I think the majority of the types of questions will be that type of question. So that's what I am concentrating on. It doesn't mean to say you can't have a one-tailed test. What I'm saying is let's get a two-tailed test right, because the majority of questions are like that. Right, so step 2, what are they giving you? Where does that 0.05 come from? It comes from your level of significance. Okay, they've given it to you in the paper. The next thing, now you've got to calculate your degrees of freedom. They are not going to give you this formula. So please remember that. Okay, I've got to be very, very cautious now, because I know most students know what's on the formula sheet, because I'm sure their lecturers have handed them out and they've seen it on old exam papers. But I need to also make sure you know what you're going to get and what you don't get. You don't get your degree of freedom calculation. Okay, and it's important that you need to know this, because you've got a whole bunch more different ones in your chi test. So your degree of freedom is n, which is your sample size, which is what there were 10 people, minus 1. Okay, n minus 1. So 10 minus 1, which gives you 9. Right, now it's a two-tailed test, because you are testing to a claim, not greater than or less than. So because it's a two-tailed test class, please just remember this. And I'm sure your lecturers will have told you, but when it's a two-tailed test, which the majority of them are, you take your 0.05, which is the confidence level for the whole curve, and because it's a two-tailed test, you're going to divide it by 2, because you're looking at both tails, okay? You're looking at both tails of confidence. So you take 0.05 and you divide it by 2. If you have, and here's another rule of thumb for this section of work, no matter what your level of significance is, if it's a t-test and it's two tails, which most notably it will be, divide your level of significance by 2. Okay, write it in red, jump up and down on it, remember it, inscribe it somewhere. Okay, because then you're ready to go. Okay, so you've got 2 numbers here. You have got 9 and you have got 0.025. That comes from dividing 0.05 by 2. Okay, why by 2? It's a two-tailed test. So the 2 numbers you need to go to your T table, not your Z table. You're doing a T test. Why are you doing a T test? Because my sample size is less than 40. Okay, so I'm doing a T test, so it'll be the second of the tables that you work with, and the T test will have degrees of freedom on the left, and then you will find your probability. So you will run your eye down the t-table until you get to 9. 9, why? Because that's 9. And then you will run it along the top till you get to 0.025. And then you will find the number, which is, by the way, your t-stat, or actually in statsy speak, it's the number of standard errors from the mean, but you don't need to worry about that at the moment. Just make sure you, well, you do. I mean, please, I'm not, but it's more important that you get the number right at this stage. And it'll be plus minus 2.262. Why is it plus minus? Because it's a two-tailed test. All right, so you got, now class, you've got something to work with. You've got your claim, and now you've got your two bounds. You've got your two boundaries of confidence. Okay, so minus 2.26 and plus 2.262. Okay, what does that mean, class? That's important. It means the following thing. If the number that you get in step 3 falls between, well, as I've got it here, minus 2.262 and plus 2. You can accept it, or you don't reject the null. Let's not confuse ourselves. Let's say you accept the null, all right? So you know what you're doing. So you're accepting the null. And if you accept the null, let's go to the null. There's the null sitting there. There. If you accept it, you are saying that is true. The claim is probably true. Okay, so those are the numbers here that you are going to check where the number in 3 falls between or not. Hey, it doesn't have to. So now we use our t-stat. Why are we using our t-stat? Go back. Go all the way back to the thing I showed you. There's your t-stat. There's your calculation. It's not a proportion because it hasn't got a percent. Okay, so I'm just making sure you know where you're going with this. You plug the numbers in that you've been given. There's the claim. Well, not the claim. There's the claim, sorry. There's what they found. And you did the calculation and you got minus 0.47. Try it out when you have a bit of chance, class. Make sure you get to it. Now, lastly, and this is quick, you don't have to write piles of, you don't have to write half a page. Because this number falls between those two numbers, what do we know? It means it falls within the region of acceptance. If it falls within the region of acceptance, class, you accept the null. And if you accept the null, class, it means you accept that the claim is probably true. And you write that all up in one sentence. And you say, and you tell the examiner that your T number falls between those two numbers. Therefore, we don't, statistically, you're supposed to say we don't reject the null. But quite simply, hey, you do not reject the null means accept the null. So you choose whichever one you find happy with. Just don't say you reject the null, because that means then you accept the alternative. So you say accept the null. There we go. And then conclude that the claim is, and this is very important, probably true. You can't say anything in statistics unless it's death and taxes is true. Okay? So you always say that word probably. If you put that probably in, and again, class, I'm teaching it as the way I teach my own students. Your lecturers may tell you to do step 4 and step 5. Then do what your lecture is. I'm not, please, I don't want to get you getting into trouble or losing marks, but that thing there actually encompasses step 4 and 5 very, very quickly and very, very easily. Now, this whole thing, if you do it properly with step 1, step 2, step 3, and step 4, will take you just on a page. Okay, and a page for 10 marks is not bad work. I dare any of you to try and get 10 marks for business management that easily. Okay, but don't quote me on that. Right, moving on. Okay, that's using the Z table. We're going to use proportion. Now, remember I said there were 2 types of questions. One of them is a T, kind of, if your proportion's less, if your population's less than 40. The other one, class, is a proportion. Now, a proportion has a percent. A percent is categorical data. Why? Because 19% of clients class are nominal data. Go back to chapter 1. Remember your difference between your qualitative and quantitative data. What's the weakest form of data? That's a question that perennially comes up. The weakest form of data is nominal data. What is nominal data? It's gender, it's people, it's discrete, It's data that you can't put integers on. That's what most importantly. All right, so these are clients. It's categorical data. 19% of them are based in Durban. You must test the claim. Remember what I said to you about hypothesis testing? It's all about testing a claim. And you now hopefully know that when you start the process by saying, what claim am I testing? That's step one, is what is my claim? What's the claim that I'm testing? Step two is what are the numbers that the step three must fall between? And bang, you're there. It's as simple as that. Please don't complicate it. And the other thing, students, is don't try and, okay, this probably doesn't sound clever coming from a lecturer, but don't try and understand every step. If you understand the process and you understand what you're trying to do, it falls naturally into place. It's a bit like maths in a way. Don't try and learn this rote, because then you're going to get it around the wrong way. Get a feel for what you're doing, which is what I'm trying to teach you, and then go for it. So, but there's a couple of rules of thumb. If you're going to do a hypothesis test with a percent, then it's going to be a proportion type question. All right, so let's start. Number one, we've been given, but this is a proportion question, so let's know exactly what we've been given. We've got a sample size of 710. Let's go back. Where's that from? There, 710, okay? Sample, okay? Sample proportion, I'll come back to. I'm going to leave that. Your pi is 19. Why? That's what you are given. Or should I say, sorry, what your claim is. Pi is your claim. It's not that geometric thing you use to calculate circles. Pi is the claim, all right? That's very important. Pi is the claim. Okay, so pi is the claim. Let's go back again or forward. That's the claim. That's what they've told you is a level of significance. And then now what the hell's this? Let's go to look at the question and understand what we've done. So remember, as with your sample mean, you were given the claim and you were given what they found. The P is what they found. The pi is what you were given. So the pi is 0.19. The P is what they found. What have they found? They found 143 out of 710. So convert that to a percent. There, 143 divided by 710, and you've got your P. Okay, and we'll see where it goes in now. So step one, go back to process. What's the claim? The guys are saying it's either equal to 0.19 or not equal to 0.19. Why? 19%. Remember, decimalize the percents. That's number one. Number two, class, remember that when you're dealing with proportions, you're not putting that mu, that little u. That's for a sample mean. For a proportion, you're going to use this pi, okay? But that's pi. It's not the same pi as for geometrics. Now you've got everything you need here. So you step one, you've defined it as a two-tailed test because you're testing to a number. And you're just going to say it will be rejected if the evidence is either above or below your critical value. Right, lekker. Number two, determine the region of acceptance. Now you're not using a t-test here. Why are you not using a t-test? Well, if you're using a proportion, and a proportion uses a z-test. Let me go back. I'll show it to you at the end. Right, now, students, this is something else that I'm pretty sure your lecturers have taught you, but I'm now going to make sure you understand this. In your z-test, unlike your t-test, you had to find degrees of freedom, and you had to calculate. Generally, if it's a two-tailed test, you had to divide your significance by 2. Great, lekker, we saw that in the previous example. In a z-test, you are not doing any calculations. All you're doing, class, please make a note of this, is you are remembering 3 numbers from table 8.1 in your stats book. If you don't have a table 8.1 in your stats book, or you don't have a stats book, my suggestion strongly is to just photocopy that page, because there are 3 numbers that you need to know, okay? There are 3 numbers that you need to learn, because they're not going to give it to you in your exam. There are ways of getting them from the Z table. I'm not here to confuse you. So I'm telling you the easiest and quickest route to go. The 3 numbers that you must learn line up with the 3 confidence or levels of significance that they are going to give you or could give you. So we understand they can give you 99% level of significance, 95% level of significance, or 90% level of significance. Those are the three. They're not going to give you 97.5 or anything like that. So class, what I'm asking you to do, because this is actually very important for a Z test, you will get a proportion test, I'm pretty sure. Okay, I don't know the T test or the Z, yeah, but you will get a proportion test. And if you get if you do this instead of the chi test, then class, you are going to be given one of 3 levels of significance. You've got to learn the numbers that go with each level of significance. If the level of significance is 10%, then it is plus minus 1.645. Okay. If the level of significance is 5%, in other words, lining up with 95% confidence, then you're going to learn the number plus minus 1.9. I think it's 46, I think something like that, or 996, sorry, plus minus 1.96. And if the level of significance is 1%, it's plus minus 2.84. Now, class, or 85, I think it's 85. Go to table 8.1 in your book and learn them. They're right at the top of the table for 2-tail tests. There are 3 of them. I'm asking you to learn them, even if you don't have a book in front of you. Write that down, table 8.1 in your stats book. Go to the top of the table. They're talking about 3 numbers that are linked with 3 levels of significance. Learn them, know them, because you're going to need to use them. You're going to need to use them pretty quickly and efficiently. Okay. So in this particular example, they're testing for 10% level of confidence. In fact, that should read significance. And therefore, the number is plus minus 1.645. If it was 0.5 level of significance, then the number would be plus minus 1.96. If it is 1% level, then it would be plus minus 2.58. Okay, learn them so you can use them. Right. So in this situation, step 2, you're going to accept the stat if it falls between those 2 numbers, okay? The ones that you've just been learned. So step 2 is quick, eh? So between step 1, okay, there, and step 2, there, you probably got 3 or 4 marks already out of 10. You haven't done a calculation yet, but you've got to know these numbers, okay? You've got to be able to put them correctly. So now we go to step 3, exactly the same process. Now remember when I put all those other numbers down and I said to you, where do they come from? 710, 20% or 0.2, 0.19. This is now when you use them. You use that calculation there from that flowcharty thing. My suggestion is when you get a chance to class and this thing gets downloaded, print the thing off, or at least print that flowcharty thing off. It is really going to help you. Anyway, because it's got the formula on and which way you go. So calculate the test stat. So your P was what they found and your pi was what they claimed. They claimed 0.19, but they found 0.2. The bottom bit you can do quickly and you get 0.68. Learn and make sure you can get these calcs. So 0.68 is the number that came out. What are your boundary values? The boundary values are the one you've just, you didn't calculate, you learned them. Minus 1.645 and plus 1.645. Therefore, does 0.68 lie between them or lie outside of them? Well, patently, class, it lies between them. It's actually very close to the mean. So therefore, you can say it lies inside the region. Therefore, we accept the null, that the claim is probably true. Okay, these are not difficult at all. But I'm asking you, and I'm going to go back now. You'll see it, class. I mean, you'll get these. You'll download it fairly soon after this. This is critical. Okay, you can't take it into the exam, but it's critical because it'll teach you immediately which way to go. Has it got a number? That side. Has it got a percent? That side. Great. Now we're cooking with gas. Has it got, if it's got a proportion, then you're done. Okay, then you just follow this calculation down. If it's got a number, the next question is, what's the population size or the sample size, should I say? Sample greater than 40, Z. Sample less than 40, T. Follow your steps in. Follow them like you have learned them. 1, what's the claim? Null, alternative. What's the region of acceptance? That's the region within which the number from 3 will either fall or not fall. If it falls between those two numbers, you accept the null. If it's on either side of them, you reject it. And then your step 4 is just telling everybody what you've just found. Okay, it's not difficult, class. It really and truly isn't. But you've kind of got to know your numbers. Right, lastly, okay, now I'm going to say something which probably I shouldn't, but I'm going to anyway, because I'm old enough now to not get away with it, but this is what I think. Class, this is both hypothesis tests, the ones you've just done, and these ones are in section D. Okay, so section D, and I'll end up with this at the end by going back and having a look again at that exam. Now, section D contains 2 questions, the proportion type question and the ZT one that we've just done, or it contains a chi test. The CHI stands for chi. Now, they're both not difficult, but I'm suggesting to you, and I don't know if your lecturers will agree or not, that there are a number more of calculations in your chi test, okay, than there are in your hypothesis test. So I'm asking you to think carefully about which of the questions you answer, whether it's question 8 or whether it's question 9, okay? I'm not telling you, I'm just saying think carefully about them and the ones you feel comfortable with under a time constraint, such as is in the final exam. Okay, and I'm sure your lecturers have spoken to you about it, but I'm just re-emphasizing the point, because your chi tests have a lot more calculations. Okay, they're not difficult. We're going to go through them now, but there's a lot more of them. Okay, right. So you're going to get 2 types of questions, and I'm pretty sure, class, in your exam, it's going to be a type 1 and a type 2, because those are the only 2 ones they can ask you. All right. So type 1 question. So now, class, we've moved away from, look, they're hypothesis testing, but they're hypothesis testing on a different class of question. We're dealing with categorical data now. We're dealing with, first of all, questions of a relationship or association. So in other words, I'm a printer. I print 3 different types of magazines, 1 for males and 2 for females. I need statistical proof whether or not from my sample the women, the ladies read the particular magazine or what. So I need statistically to see that. Okay, so that's my type 1 type of association. So the question's going to look a lot. Okay, right, okay, my flowcharts again. You can see by now, I love my flowcharts because I found that's the easiest way for students to actually get a grasp of stuff I'm dealing with. Okay, please, I use this in my class, and it does help students because it manages to center them and give them an idea of where they're going. But I'm sure your own lecturers also do their own tricks as well, which is great. So use it with whatever your own lecturers use. Okay, so you get a question at the top, and then you have to decide whether it's a type 1 or a type 2, okay? Is it a relationship or is it a change of pattern? We're going to do both. I'm going to show you both of these questions, and then you can make that big decision yourself, okay? Now, you're going to do exactly the same process, step 1, step 2, step 3, step 4, but there's going to be some fairly substantive differences. You will see that the formula is different. They're both the same kind, really, except that segment needs to be at the top, not at the bottom, but that's my bad, and I'll show you. But the degree of freedom calculation is different and different and different from hypothesis. Okay, class. Now, I can't remember, quite honestly, I can't remember if they give you a degree of freedom formula in the back. I really can't remember it, and I don't know if they have for this one, but I'm saying to you, learn them anyway. Notwithstanding what anyone else says to you. Learn them if you're going this route, okay? Learn all of those degree of freedom calcs and where they apply. All right. Now, that you can look at this all day. It's not going to really help. So rather, let's get in and understand the kind of a question. So first of all, you're going to use this formula in step 3. So in the last hypothesis tests, you used 2 types of formulae. This is going to be your formula you use for a chi test. Okay, again, my bad. This should be at the top, but we'll get there. I'll show you what I mean. One's expected frequency, one is observed frequency. That doesn't mean a lot at this stage. So let's take an immediate exam example and go through the process. All right. So an exam question, a test of a relationship. How do we know it's a test of a relationship? Because they generally ask you and they say, we wish to determine whether there's a relationship between gender and preferred brand of cell phone. So there you have male, female, you have Apple, Nokia, Huawei, and totals. Right. Very much like class, if you can go all the way back to probability, probably section C, like a kind of a question is, what's the probability of randomly selecting a male out of it? So you see 102 out of 200, the one of those. So it's exactly the same type of question. Not question, same type of table. But you'll get a table with a question 9 like this. All right. What this has got a different question to it. It's not asking you the probability of randomly selecting people from it, or people who are male and like Nokia and stuff like that. We now want to know whether there's a relationship between male and female in those phones at the top. So you've got to perform an appropriate test to determine whether there's a relationship or not between gender and brand. Okay, so that's a Chi test. That's a question 9 in the exam. It's your final, it's in your section D, the final 2 questions, right? So if you're going to do this class, then you are going to start by saying, right, it's a relationship or an association. I'm going down this road. Okay, this road takes me to, there we are, finally. There, it's right, I finally got the correct formula there. And then you use that degree of freedom. Okay, that you can only use this degree of freedom with this formula. All right, so now we start. Now we're defining, hey, exactly what we did in the previous one. Step 1, step 2, step 3, step 4. Exactly. But there's some subtle differences with calculations. First of all, when you write your null, you don't write any numbers. You're just going to say the null is that. And for me personally, and you'd have to speak to your lecturer about this, I'd say the null hypothesis, there is no relationship. Alternative, it's always HO and H1, there is an association. Okay, so either they are independent and there's no association, or they're not independent and they are there is association. So the null is no association. The alternative is there is. So what are we doing in this test? We're trying to find with a certain level of confidence whether there's an association or not between gender and things that they read or whatever it was. So the first thing we do, that was step 1. Eh? Step 2, class, we first of all need to understand, because that this funny little X is called it's a chi, it's a sign, it's chi, and it's called a chi-square test, and it's only an upper tail test. So unlike your hypothesis tests, which could have been 1 or 2-tailed, this is a 1-tailed test. Direct, just that's it. Next thing, you need to find the critical area, the level of confidence, and the degrees of freedom. So that's what they've given you. Oh, sorry, hang on, my mistake. That's what they've given you. So the first thing is we need to go to the, let's go back here. This is where things get a bit, not use a degree of freedom calculation, because that's, you need that number to go to your table. Right, so number 1, let's go and do it. The sigma level is 5%. They've given that to you in the question. And degrees of freedom, R -1, C -1. R stands for row, C stands for column. How many rows excluding the total? 1, 2. How many columns excluding the total? 1, 2, 3. So 2 -1, R -1, and 3 -1, 2 -1. So 2 -1 there, 3 -1 is 2, which comes to 2. All right, when you multiply them together. Right, now you take the 2 and you take your 0.05, you go to your chi test table. The chi table is not the Z or the T, it's the number 3 table, right at the back of your exam paper. And you go to number 2, right on the extreme left, run your eye down, go to 2, run your eye along, go to 0.05, and you'll see a number there. That is the number, that is your chi test, and that's your critical value. If the number in step 3 falls below this number, then you can say everything remains the same. If it's higher than that number, you can say that the alternative is true, exactly as I have it here. Why is it greater and less than class? It's because it is a one-tailed test, not a two. Right, next thing. So we now are going into step 3, and step 3 is a calculation. Right, we're going to use this calculation class, but the point is we don't have all the info at the moment, so we have to find our expected frequency. We've got our observed frequency. We have to find our expected frequency. How do we find our expected frequency, class? Well, this is now what I suggest to you, okay? If you're going to do this, and please, I'm not telling you one way or another. There's where this is the table they give you in the exam. That's going to appear in your exam paper. Right, you can't do much with that. So you take that table and you kind of pivot it. Okay, so it's instead of male and female with apple and things on the top, you pivot it down. So you now write all your observed frequencies down like that. They're exactly, so let's take apple and 20. Let's go back. It's exactly the same, apple and 20, etc. So all I've done is I've pivoted that data to a vertical kind of look. Now we've got those are our FO, those are our observed, but we don't know what our FE is, class. So we got to go and jolly well calculate it. And the FE for each of those observed, you've got to calculate it for each one of the observed. So I'm going to do one for you, and then I'm going to show you how it works. So how did I get to 32.8? Well, you take the total of female, and I'm going to go back and show you, and the total of apple, and you multiply them together. So let's go back to the table. There's the total of female, 98. There's the total of apple, 67. Right. So we take 98 and 67 and multiply them together and divide by the total number of people. Okay, that gives you 32.83. That is statistically what you would expect from that number of people, and apple and females who enjoy apple. That's what I'm trying to say. Statistically, it's expected to be 32.83. This is what you found. You run those calcs all the way down, okay? They have to be different. So this one will be female and Nokia. This one will be female and Huawei, etc. Taking the totals of female and the total for Apple, Nokia, and Huawei. Now you're going to take the total for male and the total for Apple, Nokia, and do the same calculation to get an FE. Once you've got that FE, now we can do the calculation. So for each line, class, you take FO 20 minus 32.83 and square it. That's the number there. Then 35 minus 32, square it, and then move all the way down. Then after that, look, you can do it in one go, but I'm trying to explain how it works. Then you follow the final bit, and you take that number and divide it by FE to get 5.014, and then go all the way down. Finally, class, you take what it tells you to do there, and that is sum it all up. Okay, and you get 16.43. Now, class, I know your lecturers have been through this. And I'm pretty sure this is just revision. But what I'm saying to you, and please listen to me, I'm being serious with this. No, if you're going to do this, and there's nothing wrong with doing it, but I'm just saying get your calcs sorted. Know exactly what you have to do when you do it, so that by the time you come to adding it up, you don't have any issues here. Because in your exam, you're given half marks on this and that column, okay? So it'll be 1, 2, 3, 4, 5, 6. I think it'll be 6 marks, half marks. So 3 there, 3 there. If you make one mistake here, it throws out that number there, which can throw out your whole conclusion. So I'm saying, please be careful. And if you're doing it, be very cautious with it. Okay, so you got 32 point. You got a big number, actually, 32.83. 32.83 sits well to the left, the right of 5.99. Therefore, class, you can reject the null, where it lies well outside the area, and reject the null and accept the alternative. Let's finally quickly say what was the alternative. Oh, sorry. Alternative there is an association. They're not independent. Now, class, this is not difficult at all. But what I am saying to you is, and I mean this now, I want you to think about it. Sorry, before we do the last one, and then look at that, okay? There are 6 calculations there. There are 6 calculations there. And if you split them up, there's 6 calculations there. There's 18 individual calculations. Then number 19 is when you add it up, okay? Now, I want you to think about what I'm saying to you. It's not difficult, but if you make a mistake in here, you're going to probably throw that number out. If you throw that number out, you're going to lose your conclusion. Now, just bear with me if I go to one of these. Here, class, in your step 3, there's your calculation, right? And you go to your calculate and you go to your conclusion there. There is your calculation. You got maybe 2 or 3 steps at the max. So think about it. I'm not trying to sway you, but I'm saying think about the way it works. Okay, right, lekker. Last one, and then I promise you're done and dusted. Okay, right. The last one's pattern change. In other words, that the first one was these are QUAT tests, question 9. Okay, in your exam paper. Now we've got a question where is there a change in the way things have happened? The first one, is there a relationship? The second one, is there a change in things have happened? So in this situation, the financial manager of a store has found that from previous experience, 50% of clients pay by credit cards, 30 on account, and remainder by cash. He wants to know if this is still the case. Right. So this is what they have given you using a 1% level of significance. Great. Now, this actually doesn't have the same level of calcs, but it's still. So the first thing we know is that it's a change of pattern. Well, why? I mean, if you can't remember anything else, it's not like a big table like the previous one. The big table here, that's your QI test, all right? They got to give you male, female, and gender and all sorts of things. Here, they're just going to give you the thing that possibly has changed in pattern terms, right? Using a 1% level of significance test whether the payment pattern has changed. So what are we going to do? We're going to go this route down. Now note again, students, that there's a different degree of freedom calculation here, but we'll get there when we get there. Right, next thing, define the null and define the alternative. So class, okay, how do I say this again? Even if you kind of start doing it and then you don't want to do it, just put down the null and alternative and you'll get yourselves a mark or 2. So in the situation, for association, the association hasn't changed, or it remains the same. With this, its payment method has not changed, or it has changed. Okay, so the null is nothing's changed. It's as it was. Determine the region of acceptance. Now again, you have a different degree of freedom. You've got degree of freedom of K minus M minus 1. I can't remember if they give this to you in the formula sheet. My suggestion is, or what the new one looks like, but my suggestion is learn it if you're going this route. K is the number of categories. Categories class, you had cash, credit cards, and whatever. So that's the 3. Class, just remember, for M is always going to be 0. Let me say that slowly. M is always going to be 0 for the questions you do. M is always going to be 0. So your degree of freedom is going to be 2. Always 2. Okay. Go to QI test. Go to degrees of freedom of 2. Go to 0.01 and you'll get a critical region of 9.21. What does that mean? If the number falls to the right of it, it means you reject the null. If it falls to the left, you accept the null. If it falls to the right, there's definitely a change, or there's been a change in pattern. If it falls to the left, there hasn't been. Now with this one, class, the question is such, they've given you 600, 250, 150, and because that's what they found, and what they have from previous experience, class, 50, 30, and 20. Now, what I want you to now understand what we're going to do here, oh, sorry, my apologies, is what we've done now is there's the observed, which was 6, and let's work out what have I done here. So let's go back to this question. It's out of a total of 1,000, okay? And it's 600, 250, and 150. So that's what we found. That's what we've observed, okay? So the observed is 600, 250, and 150. What did they expect, class? Was 50%, 30%, what has been from previous experience. My apologies. This is what they found. This is previous experience. 50% on credit cards, 30 and 20. But you can't work with numbers and percents. So you've got to take the expecteds and you convert it into a number. So 50%, and this totals to 1,000. So this totals to 1,000. 500 out of 1,000, 50%. Let's go and see where that comes from. 50% pay by credit card, 30 on account, and 20 by cash. 50% credit card, etc. So you've converted the percents to the total number to make them consistent with the observed. Okay. Now, class, you've got the situation is very much quicker than in the first one. Okay, so you've already got your FE. With the first one, or the first car, you had to make and go and do a whole bunch of calculations. Here you've done it fairly quickly, so now you just run it again through that formula and you get 40.83. 40.83, with due respect, is well north of your figure here. Remember here, your significance level was 9.21. You got a significance, or you got a final chi test of 40.83. That's well north of what you are expecting. So you can accept, you're going to reject the null, accept the alternative, conclude that there has been a change of, in patterns. Right, you lot. You've done very well, actually, I must say. I mean, honestly. So what I'm going to do quickly is I'm just going to quickly go all the way back. I want to go back to the exam again now, because we've done a fair whack of stuff here. It's all going to be loaded up soon. You can see there's a lot of stuff here. What I want you to do now, please, class, is here. Here we go. And this is all going to be loaded. Section A, compulsory. Now, with all of this in the back of your mind, okay, I promise we're nearly done. There's a compulsory section. You can't get out of not doing that. So you've got master classes on index numbers that are comprehensive on your index number and linear regression. Please go over them. You've got a master class on the grouped, actually your master class is the first one, definitions and index numbers. The second one is linear regression and group to ungrouped data, okay? You've got them loaded, go over them. They're much better than me trying to rush through everything in about 3 hours. What I've done this time is I've gone through very slowly in terms of your probability and your distributions. And let me remind you again so that you can make a considered decision. Do you go the probability tree and the frequency table and permutations and combinations, or do you go binomial, Poisson, and continuous? Do you go the hypothesis test, which is, what we've done, the sample mean or the sample proportion, or do you go the chi test of association patterns? I'm not here to tell you which way to go, class. My suggestion is choose, in this one, particularly the one with the less place where you can make a calculation mistake. Here, it's really up to you. It's the ones you feel familiar with. Okay. And apart from that, hey ho, that's it. So well done. You've been a good solid 2 hours on this today without any break. Well done, students. I wish you all the best. This is now going to be, okay, it'll take time to get downloaded. I'll have it sent out to the powers that be. It'll be loaded by this afternoon. My suggestion is take the second and first masterclass, run them to not today, that would be silly, but over the course of the next 2 weeks, when you have a chance, run them, listen to them, and by all means contact me or your lecturer if there's any issues. Also remember, if you can, get hold of a formula sheet from your lecturer to tell you exactly what is in the exam, but more importantly, where you find it, because they're sometimes scattered all over the place on the formula sheet, and I don't want you wasting unnecessary time trying to find the formulae, okay? Just remember, probabilities are not on there. Apart from that, ladies and gentlemen, have a lekker one, work hard, enjoy stats, get distinctions, and yeah, hopefully you'll all be through in about a month's time. So ciao, and if there's any questions, just shout. Other than that, bye, and it's now done. Thank you.